Thank you, guys. And this is the third time to welcome join the training. And today is the third day. And about the wireless part, maybe today finish, we will have half topic finished. Okay. Of course, before we talk about the detail of today's topic, let's also have a brief summary of yesterday. Yes. At the beginning, we explain the topology for you, right? We hope after finish the training, you can do the function like the right technology in your network. In the first day, we talk about the IP address, L2 VPN, L2 switch principle, and the VLAN. And yesterday, we talk about the STP, spanning tree protocol, and the link aggregation. And about the STP, why we need this technology? The reason is in our network, if we only have only one path or maybe one devices in the main path to follow the traffic. If one link is broken or maybe one device is broken, the network cannot working. So this problem we call a single failure. So we hope we can increase the multiple devices or more links to provide a backup function. But like the topology, if we use lots of devices like here, there maybe is a loop, right? If in our network we have the loop, the MAC address table will delete the same information, add, delete, add all the same time. So this is the effect of the loop. And the message will be forwarded all the time until the devices like the switch, like the host, like the gateway devices don't have any resources like the CPU. And finally, the network is broken. And then the traffic will be discarded. So this is the high risk of the loop. So how to avoid the loop? We can use the spanning tree protocol STP. And in the STP, if we add the configuration of the spanning tree, then the STP will select who is the root according to the bridge ID. And about the bridge ID, the first 2 bytes is a priority, and small value is better. And if the priority is same, we will compare the MAC address. Also, is smaller is better. So according to the bridge ID, we can select in our layer 2 network. Pay attention, STP is in your layer 2 network, not about the layer 3, like the router or layer 3 switch. And then the rest of the devices will become the non-root bridge. And in the non-root bridge, we will select one API in one switch, right? Compare with the cost value. Of course, we have to compare the cost far away from the root bridge. And smaller cost value means higher bandwidth. We will think this interface will be better. If the cost value is same, we will continue to compare the bridge ID. Also, the same principle. Smaller value will be better, and if the bridge ID is same, we will compare with the port ID. And the port ID is combined of the port priority and the port number. So finally, we can select one root port in the non-root bridge. And then one link, at least one DP. And this DP finally will be used to force the traffic. And the rest of the interface will finally be selected to become the AP, LNet port. And about this LNet port cannot force the traffic until some normal link is broken, and we will recover again to select some broken interface to become DP or to become RP to follow the traffic. So this is a main rule in the STP. And about the STP, we have two types of BPDU, bridge protocol data unit. And all the switch will transfer this BPDU to calculate the rule and finally to blocking which interface. And another BPDU we call is TCN BPDU. When the network topology change, for example, one link is broken or maybe add a new link, we have to do the convergence again. One reason we have to make sure each interface's rule is changed or not. Otherwise, maybe there is a new loop. The second one, if your network topology changed, we also have to reflect your MAC address table. Otherwise, the devices will force the traffic according to the old MAC address table. Maybe you cannot force the traffic out successfully. So if you have the TCN BPDU and have some TC message, then you can make the refresh time from 300 seconds shorter to become 50 seconds. So this is the advantage of the TCN BPDU. But in the STP, we also have lots of problem, right? One main problem is, although maybe we select an interface to become RP or DP, we have to wait the interface state to become forwarding state. Then we can forward the traffic to help the devices to forward the traffic. And by default, the time is 30 seconds. That means if you use a cable to connect with each other, you have to wait at least 30 seconds later, then you can force to wait the internet resources. And in this time, although maybe one link is broken or one device is broken, we have the TCN BPDU to shorter refresh time of the MAC address table. Also, we have to wait 30 seconds, at least. So this is the biggest problem of the STP. And we also have some advanced feature of the STP like the port faster technology. To make some interface can directly enter the forwarding state to shorten the time. This is an advanced feature. And another technology, maybe in the future, we will have a chance to discuss together, like the ISTP, like MSTP, to make the time shorter. But another one, in some special scenario, we will use a new technology we call it link aggregation. For example, like this topology about the distribution switch, we have two links directly to connect with each other. And about the distribute switch or maybe some core switch, it will have higher bandwidth interface. We hope we can let all the link to forward the traffic. So in this scenario, if you use the STP, at least one interface will be blocked in order to avoid the loop, right? So if we use the technology of link aggregation, we can combine multiple physical interfaces to become the logical interface. And all the link can be used to forward the traffic. Although one link is broken, we also can transfer the message by another link. So this is the advantage of the link aggregation. And about the link aggregation, we have two types. One is a static link aggregation, and another one is dynamic. Static means I will do the aggregation site by site. I don't care about in my other site will become the member or not. I only care about my site. And the second one, if you use the dynamic protocol, we will use LACP in the devices, and we will send out the LACP message and to select who is a special interface, and then according to this interface, finally we will select the member ports. Okay, so there are two types. And about the link aggregation, we also have some limitation. For example, the maximum member is 8. In some special series, we have limited the number to become the 8. And if you use LACP running in your devices, and another special thing is we have two types of dynamic link aggregation. One we call is active, and another one is passive. The passive is special. I only send you, give the LACP packet to you until I receive the message. Then I will reply it. Otherwise, I'm waiting. So when you do the configuration of the dynamic, at least one site, the type should be active. Okay, so this is link aggregation. And today our topic will discuss a new technology we call is VSU, because although we think the link aggregation is better than STP, right? But some scenario like this topology, if the access switch also can use these two interfaces to become the uses a link aggregation, but this cannot work because we have two link and to connect with different upper devices. So in this scenario, the link aggregation cannot be work. So if we use the VSU on the distribute switch to make two devices to become a logical devices, then the link aggregation also can be used on the access switch. So link aggregation is a technology to combine multiple interfaces to become a logical interface. But about the VSU is used to combine multiple physical devices to become a logical devices. So they are two different technology, but also both of them in order to use in the network to prove the network reliability. So this is a function. And later we will see the detail of the VSU. The VSU technology principle. First, we have to know the full name. VSU is a virtual switching unit. Like the name, this is the technology for switch devices. And this is a virtualization technology, and we can combine physical devices to become a logical one devices. So after finish this one advantage we call is the access switch or maybe the upper router, we can use a link aggregation. Another one is if we do the configuration, we only need to log in one devices, then all the command can be directly cross these devices and then to send this command to all the devices. So this is easy to do the management. Okay, so this is the advantage. And we hope after taking this course, you can describe the basic concepts and the principle of the VSU. That means why we use the VSU and what's the advantage and how to work. And the second one, you have to know the basic configuration of the VSU. If you want to deploy the VSU in your network, what is a key configuration? First, let's see the overview. Why we need the technology of VSU, like this topology, right? We have the typical network type, access layer, distribute layer, and the core layer. And about the distribute layer and the core layer, there is a loop, right? And maybe we will use the technology like STP or RSTP or MSTP to avoid the loop and also can provide some redundant link. But pay attention, yesterday we talked about the principle of STP and explain some key command of the STP. The configuration is very easy. But the disadvantage is in the STP, if one link is broken, this link cannot force the traffic all the time until reconvergence again. And we select the block interface to become forwarding. Then this interface can work. So if you also want to use this link to forward the traffic, one maybe the scenario is useful, you can use a link aggregation. Another solution, maybe you can use MSTP. But about the MSTP, the configuration is very complex. And if in your network you have lots of devices, the configuration will be more complex. So to provide the redundant gateway, of course, later we will talk about the technology of the VRIP. Usually we will use the VRIP and MSTP together. But how to make the network easier? Another solution is we can use the VSU. So this is the traditional reliability network. We have lots of disadvantage. The first one is complex network technology. We have to know. You have to know the principle of this STP and VRIP. Then you have to know the command, then to do the configuration. Later, you also have to do the troubleshooting. And the second one, the fault recovery time is typically in the range of seconds. For example, like the STP, if it's a redundant link, we need the redundant link to work. At least 30 seconds you have to wait. But it's too long for us. For example, now I let you to wait me 30 seconds, right? The time is too long. And the third one, some links are blocked and the link bandwidth resources are wasted. So this is the main three disadvantage of the traditional reliable network. And if we use the VSU, this is the new technology. We can combine multiple devices together to become a virtual switch. Although the same topology, we have the access switch, we have the distribute switch. If we use the VSU together, finally, this will be a logic devices for us, right? So for the customer, the logical topology will be like this one. We only have two access switch and one logical distribute switch, and we have multiple links to connect with each other. So in this scenario, we can do the link aggregation together. For the access switch, they will think I only have one up layer switch, and I can use the link aggregation and finally to use all the bandwidth in the same time. And I also can provide some load balance function. So this is the advantage. So use the VSU, we say we can provide a higher reliability network. And the advantage of the VSU, the first one is the management. Administrator, our manager, only need to connect one device for unified management because later I will show you the detailed concept. If we have the VSU, we will select one master. And every configuration, we can direct log in the master and do the configuration. The second one, we can streamline the network topology, connect the aggregate link and perhaps and no layer 2 loops and no need to configure STP protocol again. And we also, this is the protocol of the layer 2. And about the other protocol like OSPF. OSPF is a dynamic routing protocol. Within the VSU, maybe we have several devices, 3 or 4 devices, and combine together. Between them, we don't need to run in OSPF again because logically this is one device. And also we don't need to run the PIM. PIM is the protocol of the multicast. If in your network you use a service of the multicast, maybe between the router you will choose the protocol of the PIM. And SNMP is a management protocol between the controller and the devices. And we can select a lot of devices resources from this protocol. So between these devices, in the VSU, we don't need to run in this protocol again. It's very easy to maintain. And another one is fault recovery time reduced to milliseconds. The failover time will form from 50 to 200 ms, milliseconds. So this also is an advantage. If one device is broken, maybe we can immediately to select a new one and working again. So this also is an advantage. And another one, we can improve the bandwidth utilization, right? Because all the link within the VSU or maybe the VSU devices with the access switch or maybe core switch, all the link we can use link aggregation together with the VSU and then all the link can work. So this is the advantage of the VSU. And later, let's see some basic concept of the VSU technology. In the switch, first you have to support this feature. Not all rigid devices will support the feature. That's why maybe in some scenario you only can use the STP or maybe only can use the link aggregation because the devices have to support the VSU at first. Okay, and if the devices supports the VSU function, Then the switch will have two working modes. One is standalone. This is a default mode. That means if you give the power and use the cable to connect with each other, then they will working alone. This is independent devices. This will have the MAC address table belong to themselves. And also maybe this is a layer 3 switch, we will have the routing table, something like this. But if you want to use this VSU function, you have to change the mode to become the VSU. Okay, also later I will show you the command how to change it. And in the VSU, we have lots of concepts like the domain ID, switch ID, priority, and in the VSU group, we have to select one devices to become the main chassis, we call it master, and another one for standby. Also, maybe we have the third device, have the fourth device. They have their own rule. And how to select who is a master, who is a standby, we also have some principle. And maybe about these devices, we have two plans. One is control plan and another one is data plan. Control plan usually is used to do some calculation like the routing information, like the MAC address restore, something like this. And finally, to get a forwarding table, then your data plan will help the traffic to forward help the devices to forward the traffic. And about this plan, we call it data plan. So after we use the VSU to mix the devices together, maybe one device is one control plan, one data plan. But if you have two devices, only one control plan will work to do the calculation, like the brain of people. And all the devices data plan can forward the traffic and according to the forwarding table from the brain, from the control plan of the master. So this is a basic one. And about this page, you only need to know we have two modes, one for standalone and another for VSU. The key point is if you want to let the VSU mode work successfully, you have to change the mode to become VSU. So this is the working mode. And later I will explain one by one what's the key parameter of the VSU. And when we do the configuration, maybe some scenario we have to care about these parameters. The first one is the switch ID. And the switch ID is the main ID of the switch in the VSU and the range from 1 to 8. So this is the member ID, and the range also limits how the maximum number in the VSU. And by the default, the number is 1. And in the standalone, we only have two-dimensional format. That's why when we do the configuration, when we enter the interface, like gigabit Ethernet 2/3, right? And because we were directed to ignore the switch ID, because everyone's switch ID is same. And the 2 and the 3, 2 is maybe is the service line number and the 3 is the port number. And about the VSU mode, we will have 3 decimal format because we have to add the switch ID. In the VSU, different devices, different switch ID to distinguish different devices. So like the example, gigabit Ethernet 123. 1 is the member number, and the 2 is the slot number, and the 3 is the port number. Okay, of course, maybe when you use the normal switch, you will find the second number will become 0. That's because you only have one slot. If you have multiple slots, like some high performance devices, you will see the interface like 2/3, 5/3, something like this, because you have lots of slots in the devices. So after we finish the configuration, you use the command show switch virtual. The first one parameter is the switch ID. And the noted is we have to ensure that the device's number of all the devices should be unique in the same VSU. Maybe in your network you have multiple VSU, it doesn't matter, but within the same VSU, the switch ID should be different. So this is the first one, switch ID. And the second one is about the domain ID. And the domain ID is used to identify the VSU devices and usually to distinguish different VSU. Maybe you have multiple VSU. And the domain ID of two switches, if several switch in the same domain ID, the domain ID should be same. Pay attention about this part. Otherwise, maybe they will belong to different VSU. And the value range is from 1 to 255. The default value will become 100. And in the non-VSU status, we have to use the command switch virtual domain and gives the value. But in the VSU status, we can directly enter the VSU domain configuration. And this is a key command if you want to enter different devices. This is the command config the domain ID, which switch and what's the domain ID. And we can save it after we finish the configuration. And use the command, this value will be the second line. Domain ID and in the same virtual switch and all the domain ID will be same. So this is a key point we have to know about domain ID. They have to become same. And the third one is the priority. Priority is used to select finally what the rules the devices will be used. Maybe you will be the active switch, like the master, and maybe is a standby, maybe is a candidate. So we will compare the priority. But about this priority, the principle a little different. The larger priority will be better. Okay, and the range also is from 1 to 255. The default one is 100. So in this VSU, we have 4 switches, and the first one will select to become the active because the priority is 200. And about this value, we have the first 200 and then the second 200. The first 200 means the priority of the current operation. But in this 200 means the priority of the current configuration. Usually, for example, when you do the configuration and you save it, when you finish the configuration of the VSU and save it, you have to restore the devices. This priority will be same. Otherwise, the default value is 100, and maybe you give the configuration will become 200. So this is a little different, the priority. Okay. And the second one is the status. We have to check the VSU can work normally or not according to the status. And we have 4 status. The normal status is okay. Okay means now the operation is normally, and finally this is a steady state. Maybe the active devices will calculate the routing information, some MAC address information, and then to give you the forwarding plane. So this is a status. And the other one maybe is a recovery. You have to consider which scenario we will see different status, and according to the status, we can to do the troubleshooting. And about the recovery means maybe the VSU system is split, or maybe the BFD or link aggregation detection is configured, and the standby devices will be in this status. For example, at first they will belong to the same VSU, but later some link between the devices is broken, and the standby devices, the state will become recovery. In the recovery devices, we cannot forward the traffic. Otherwise, maybe there's some mistake in our network. When 2 split VSU systems are merged, The side that lost the election is also briefly in this data. Okay, so this is a briefly time to take the state to become recovery. And the third one is leave. It belongs to the process state and only exists during the restarting process of the devices. Our steady state only is okay, and maybe the standby devices also cannot work because we have the split action in our network. The state will become recovery, but the leave only is a process state. And the last one is isolate. If the switch IDs are the same, for example, when we give the configuration and give the run parameters, and several devices ID are same, then one device's the state will become isolate. Okay, and in this data, all the VSU link cannot work, will be in the down state, and also cannot force the traffic. So when we do the configuration, we have to do that the switch ID will be unique in our network. And another one, devices in the recovery state will put all the interface to become shut down state. In this state, the device's interface cannot force the traffic, but except the VSL interface. And later I will show you what means VSL interface. We will use this special interface to send out some VSU message and to detect the state, for example, your active is working or not. If not, maybe we have to select a new active, like the detect packets. Okay. When the discovery state devices detect a non-recovery state neighbor, it will automatically reboot. So this is the special for the recovery state. And about the rules, we have three types. One is active, and in one VSU, there only one devices will become active state. And the second one will be standby, and also only one devices will become standby. And the rest of devices will be candidate devices. And pay attention, the active devices will do everything of the control plan, like synchronization configuration for all member devices, and maybe the time synchronization, and so on. And also maybe we do some route calculation, something like this. And about the standby, I can get everything from the active devices, and I only have one thing to do is wait the active devices is broken, and I will become the new active. So this is a function of the standby devices. And if the standby to become a new active, we will select a new standby from the candidate. So this is the principle. When the standby fails, the system will automatically select a new standby. If the active fails, the standby will directly to become a new active. And then we also have to select a standby devices again. Of course, if you only have two devices in your network, one will become active and another one will become standby. Okay. And a very important concept is about the VSL link, virtual switching link. This is a special aggregated link, and on this link, we will transfer the control information and the data stream between devices within the same VSU system. And the ports exist should be in the aggregated port group. So in these devices, you also have to configure the link aggregation, but only used for the VSL port. And who can be the member of the VSL? Maybe is the physical interface. And about this physical interface, we can be the stack ports, Ethernet ports, also optical ports. This interface can be the member. And pay attention in your network between two devices. we suggest at least 2 VSL link because this one is very useful. One is on the link, we will do the configuration synchronization, right? And also some time synchronization. And another one is after we calculate the forwarding table, we will use a VSL link to forward to all the member devices. The third one, we will use the VSL link to detect the state of active, standby, and candidate. If we detect the active cannot send out the message in the period time, maybe we will select a new one. Otherwise, if all link is broken, the state will be changed. For example, if the standby leaves the VSU, maybe the state will become recover. And then to make all the interface to become the shutdown because these devices cannot follow the traffic now. Otherwise, maybe make the loop to have a big effect of the network. So this link is very important. So we suggest at least 2 link to become the VSL link, and we will give the configuration of the link aggregation to become aggregated port. Okay. And if a high-end devices to form the VSU, it is recommended to use different line cards to form a VSL. Also is the suggestion to provide higher reliability availability for the VSL link. Maybe one slot is broken, all the interface cannot work. But if they belong to different slot, use a different line card. If one slot is broken, the other slot still can work. Okay, so this is a suggestion of the VSL link. Of course, who will become the VSL interface? We also use a command to let the devices know. This is a basic concept of the VSU. And the second one, let's see some basic principle of the VSU, how to follow the traffic, and some key configuration. And about the control plane, within the VSU, we will use a special message to follow the traffic. Maybe when we connect with the access switch will forward us using the ordinary Ethernet message to do the encapsulation, to add the source and destination MAC address, source and destination IP address, something like this. But after the message is transferred to the VSU member, the first member, and later check the maybe forwarding table, and then we will find that we have to send this message to another member of the VSU. We have to do a new encapsulation, use the HG message. And here is the encapsulation of the normal Ethernet message and the HG message. It's a little different, but you don't need to remember. After we finish the configuration, the devices will do the encapsulation automatically. But you have to know in the devices, the communication message is a little different. Okay, so this is a message. And about the VSU control principle, logically, each member of the VSU is regulated as devices with only one entry. Because, for example, for the switch 3, I will think I only connect with one devices. This is a logical devices because we already use the VSU. But in the VSU, in this topology, we have 2 devices, right? And each member devices will maintain its own entry information. That means on one devices, on switch 1, we will see the table, and on switch 2, we also can see a table. But the difference is all the member entry information is consistent. So you can see for logically, for switch 3, we only have one entry. And for itself, one devices one entry, but the information is consistent. So this is the control plan. About the control plan, maybe we have 2 devices, maybe we have 4 devices, and only one control plan is working. So someone also maybe say VSU have some disadvantage. If this active devices is broken, we need time to select a new devices to become the active. And if we do the update in our network, there are also some mistake maybe happen. Okay, maybe happen. And if all the devices split, the configuration will also have a lot of problem. For example, if all the devices cannot work, the traffic will be broken in the time until we recover the VSU. So in some scenario, if your network needs needs the traffic to be forwarded all the time, you have to consider to use a VSU or not, because if the split happened, maybe there's some problem. This is a control plan. And another one for the local forwarding. What means local forwarding? If here we use 4 devices to combine a ring and to become a VSU, and later I select a message from outside the switch, and then I will check the table, and the table will show us you have to send the message out, and the out interface is the same with these devices. So this one we call is local forwarding. And about the local forwarding, we will find the path is shortest. Okay, is the shortest. And another one is local forward first. Local forward first means if we check the information and check the table, and we found a lot of out interface, and we hope we can use the local forward at first, has a higher priority. Because if you choose the other devices to help us to forward out, although maybe you finally can forward the traffic to the destination, but in the devices, the traffic pass through several devices, maybe the path will become the sub-optional forwarding. So we hope the local forwarding first is enabled, and by default, this function is enabled. And we have 2 types, one for AP configuration and another for ECMP configuration. AP is aggregate port, right? And ECMP is a load balance way to forward the traffic according to your load balance path. And the local forwarding first function, one is for AP. The command is like this: switch virtual aggregate port LFF. LFF is local forwarding forward first. Enables the interface to make the local forwarding priority. And the ECMP is the command is switch virtual ECMP LFF, and we can enable the ECMP local forwarding first. ECMP means, for example, there is a ring, and how to go to the, like this one, how to wait the left switch. We have 2 paths, and this path have the same cost. So this link we can call this is the ECMP. And if we have the aggregate port on the devices, we hope, for example, your aggregate can forward the local traffic at first. So we have 2 different models. And another one for the noted, if we use the layer 3 devices to become the VSU, it is recommended that the user can use IP-based AP load balance and to choose the source IP address, destination IP address, or source or destination IP address to make the load balance successfully. Because the layer 3 devices for traffic can according to the layer 3 information according to the IP. And another one for the unicast forwarding. Local forwarding means the same devices receive the message, and the same devices will forward the traffic out, use different interface. And the unicast forwarding means the inbound and outbound interface between different member devices. For example, like this topology. the switch ID 1 devices receives a message, and according to the forwarding table, I will select the switch 2 as the best next hop, and I will forward the traffic to switch 2, and then the message will be sent out. Of course, in the topology, I will tell you this is the next hop, but in the real dynamic routing protocol, like OSPF, we will think one VSU is one devices. So the cost value only will be at 1. And if you use the RIP as the dynamic routing protocol, the hop only will become +1, not about 2. Okay, because this is a logical devices. Unicast forwarding. And then let's see the key configuration of the VSU. If you want to make one interface to become VSL, or maybe you want to let one devices to join the VSU, you have to add the command on the devices. So how to give the configuration? We have to know which step we have to do. So if you are clear about this part, you only to remember which command is used is enough. And about the VSU configuration, the first one for the determine the VSU connection methods. We have two parts. One for VSL, special link, only used to detect the status is ready or not. And also we can transfer some message on the VSL link. And this VSL link is used to preferred in the ring type connection. In the multi-VSL link can be used, at least 2 link. And another one for BFD. BFD is very useful. And this detection technology not only can be used in VSU, we also can use it in lots of scenarios. So BFD also is a special technology used for the detection. And the second one, you have to clarify the VSU member version. And the version have to be same, consistent, have to be consistent because they have to do the negotiation and also will check the version part. And the third part, if we check all the information is correct, and then we can do the configuration of the VSU. And we have to modify the devices mode to become VSU because we have two parts. Why? One is the standalone and another one is a VSU. And the third one, we have to configure the host detect. Maybe your VSU, maybe your BFD. So this is a key point we have to do configuration of the VSU. And how to give the configuration of the VSU? We have several parameters have to do. The first one, we have to configure the domain. The domain should be same, should be consistent if this device is in the same domain. And the default value is 100. Okay, and the command is in the global configuration site. Give the command switch virtual domain 1. And then you have to configure the device ID. After you add the configuration of domain 1, we will enter the domain configuration. Then to give the switch number, the domain ID should be same. So switch 1 and switch 2, the domain ID, both of them to become 1. But the switch ID should be unique. For example, switch 1, the ID is 1. Switch 2, the ID is 2. And then you have to give the priority because the priority will finally decide who will become the active device. And the command is switch 1 priority 200. But about the switch 2, the priority is 150. So later the switch 1 will become the active devices, but switch 2 will become the standby. And the next step, we have to configure the VSL port. Okay, the VSL port, pay attention, this port must be the active interface. You have to check for example, your indicator is green or not, and your status of the physical layer is up or not. And you also have to use the cable to connect with each other. And the key configuration is like this. In the global, give the command VSL port, and you can add the interface into the VSL port, like the interface 10 gigabit 0/15 and 0/16. Although the other side, these two interfaces must have to connect with each other. Okay. Of course, one link also can working, but has a lower reliability. Okay, so this is a configuration of the VSU, and later we have to finish we have to save the configuration and use the command WR, and the full command is write. And we have to convert the data to become the VSU mode. Otherwise, this is a standalone. Switch convert mode virtual, and then the system will ask you, are you sure to convert the switch to become the virtual mode? You have to select yes. And then he will ask you, do you want to recover the config txt from this information? You only select no because we need the newest configuration. And the same operation of the switch too. You have to change the mode to become the virtual. And also select yes and no. And later, the devices will reboot. Pay attention. In the reboot time, the devices cannot work, cannot follow the traffic. So in your network, you have to share with your customer if you add the configuration of the VSU. Until the devices reboot successfully and select who is active, who is standby, then the devices can work. So before the state successfully, the network cannot be used on the VSU. So pay attention about this part. And another one, you can configure the dual host detection. And we suggest to use a BFD. We have to add the BFD port and enable the BFD. And pay attention, the perform of BFD configuration after waiting for the VSU to be established successfully. After we establish successfully, then you can add the configuration of the BFD. And enter the global and enter the interface. You have to make the interface to become layer 3 switch, to become layer 3 port. And the key configuration is no switch port. By default, this switch interface is layer 2. So you have to change it to become layer 3 on the BFD interface. And then on the VSU domain 1, dual active detect BFD, and to show us who is your BFD interface is enough. And pay attention about this part. You will find we have two interfaces to become the BFD, but the different one is the first number. One is 1 and another one is 2, right? One is the switch in the VSU, the switch ID number is 1, another one is 2. So we will use the switch 1 and the switch to 2 devices and the port number 13 to become the BFD interface. So this is a configuration. And of course, if you use a BFD, we will send out the BFD message to detect the network, or maybe my neighbor can work normally or not. This will take some resources for your devices. So pay attention about this one. And another one, after you finish the configuration, then you can use some command to check the status. The first one is you can see the light. And about the primary light of the engineer, the master will always be green. Master also is the active devices. But the slave is a standby devices. The light will become off because after you finish the VSU successfully, we only have one control plane. And then you can use the command show switch virtual. You can see the switch ID, domain ID, what's the priority, now the status and the rule. Okay, active or standby. And after the VSU is formed, by default, the console port of slave machine cannot be managed by default. So you have to connect with the master, the active devices. But if you want to check some configuration or check some message for within about the second devices, how to do it? Because the console interface of the standby cannot work, right? You can directly on the active devices use a command like this: session devices 2, and then you will directly to enter the devices 2. Call standby 2, and then you can use the command to check or maybe some others. So that's why we say it's very convenient to do the management, because you can directly to use one console or maybe telnet into one devices. Then you can manage all the devices in the same VSU. And another one, you can use the command show switch virtual link to check the VSL information. And about the interface, VSL AP, we have two interfaces, one for the switch 1, interface 1, switch 2, interface 1, and the status is up. And another side is 2, 1, and 1, 1. That means we use the cable to connect each other. And these are the message we receive and send out, and how long time we establish the link with each other. And also you can see the VSU topology information. If you don't know the physical connection, you can use the command show switch virtual topology. And we can see the topology now. We have the train topology. Only use this is not the ring. We only use the VSL link to connect with each other. And the interface is switch 1. We use the first interface to connect with the switch 2, also the first interface. Okay, and switch 1 is the active, what's the MAC address. Switch 2 is a standby, what's the MAC address. So this is a configuration. And also you can see some load balance, show switch virtual balance, and now we use aggregate port LFF enable. And also you can show the load balance detail, the load balance based on the source MAC address and destination MAC address. If the message have different source MAC address or different destination MAC address, this information maybe will be sent beyond to different link. This is used for load balance. Of course, if you only have one link, although maybe you add the load balance, all the traffic will use the same link. So this is the basic of the VSU. And the first one, we have to know why we have to use this technology, because this is a system virtualization technology. It's a little different from the link aggregation. And if we use the VSU technology, we can make the management simply, and we can use simply topology, and we can also reduce the failure recovery time, and also can improve the bandwidth utilization. So this is an advantage. And the key point when you do the configuration, we have to know the step. First, we have to determine what's the connection method we will use. And then you can specify the version, or the member version should be same. And the third one, we have to configure the VSU and modify the mode to become the VSU mode. And pay attention, after you modify the mode, the devices will reboot. And in the reboot time, the traffic cannot be forwarded from these devices. And the last one, you have to configure dual host detection. Okay, so this is a part of our VSU. nearly 1 hour to explain about this part. So any questions of the VSU? Maybe we can write down now or discuss together.